All right, so the last section of chapter 1 is on simplifying expressions, our first kind of introduction to algebra. And we do need to start off with a couple of definitions. So the first one, and I have brought this up a couple of times. I just haven't really formally defined what I mean by it quite yet. But a term is a number, variable, or the product or quotient, so you'll usually see it as a fraction, of a number and variable. And so what I mean by this is, let's go ahead and just look at a couple of examples. Something like 3x is a term. You can also have variables that are raised to exponents, so something like 5x squared. You can have a bunch of variables in there, let's say 1/3 x, y, z. So this one we have a fraction and 3 variables, but they're all being multiplied together. You can also have just an x by itself, or just a number, so let's say the number 8. This is something we'll call a constant. It's not changing, it doesn't depend on a variable. But something like x plus 2 is not a single term. This would actually be 2 terms. So terms are going to be separated by addition and subtraction. All right, second definition here. This is for a coefficient. A coefficient is just the number you see in front of the variable, and so we'll call this the numerical part of a term. And so notice each term is going to have its own coefficient. So if we have an expression like x plus 2, like we saw above, this is going to have 2 different coefficients. So let's go ahead and look at a couple of examples of terms where we figure out what the coefficient is, because we need this in order to start simplifying expressions. So for these, we're just going to state the coefficient. And I'll go ahead and do the first one, and then I'll go ahead and just list out the others. If you want to pause and see if you can get the coefficients by yourself and then play the video with my answers, I strongly suggest doing that, especially for all the examples we're going through, just to see if you can kind of get them by yourself. It's really good practice. So number 1, we're given 3x. And so the coefficient for this is just the number in front of the x. It's going to be 3. Most of these are pretty straightforward. A couple ones at the end are going to be a little bit trickier, but go ahead and try as many of these as you can. So number 2 is 15q. Number 3 is negative 18m to the 7th and to the 4th. Number 4 is r. So just try to remember what number's in front of r if you don't see one. Number 5 is negative x. Number 6 is y over 5. This one's trickier. You have to figure out how to rewrite this one first so you can figure out the number in the front. And then number 7 is the number 8. All right, so now let's go ahead and go through each one of these. Number 2, the coefficient is just going to be 15. Number 3, the coefficient is negative 18. Just the numbers in the front, doesn't matter how many variables you have here or the exponents. Number 4, the number in front of r that isn't explicitly written here is 1. It's always a 1 if you can't see it, so our coefficient is 1. Same thing if it's just a negative, that's a negative 1x, so negative 1. And notice how the signs are always carried over to the answer for these. The coefficient includes the sign, so if it's a plus x in our expression, that's a positive 1. Y over 5, we have to rewrite this as multiplication because 5 here isn't in front of the y. But instead of writing this as 1 y over 5, because this is an entire term, our coefficient isn't just a 1 either, we can think of this as 1 over 5 y, or 1/5 y. That's because we can always write this as y over 1, and when you multiply that together, you get y over 5, which means our coefficient is 1/5. And then finally, something we're not going to see for a little while here, the reasoning behind this, but for this last one here, it's just a constant, it's a number by itself. And so when you don't have a variable that you can see here, the coefficient is just the number itself. And if you're curious why this is, one thing we'll see in some later sections is this is actually 8x to the 0 power, which means that this is just 1. But you don't have to worry about this right now. Just focus on constants are their own coefficients. All right, and one last definition before we can get into some examples. This is what I mentioned briefly in the last section, but like terms have the same variables. So in order to have like terms, you have to have exactly the same variables, x and an x, or xy, xy. They can't have different variables in each other. Raised to the exact same exponents. All right, so let's go ahead and just look at a couple of examples so we can see a little bit more clearly what like terms look like. So for these, we're just figuring out if they are like or unlike. Number 1, we're given 9x and 4x. Even if they have different coefficients, because the x's are exactly the same, then we have like terms. Number 2, if we're given negative 8y cubed and 12y squared, they both have a y, but because one is cubed and one is squared, these are unlike terms. All right, number 3, 5x squared y to the 4th and 5x to the 4th y squared. So now with this one, we have an x and a y in each. That's always the first thing to check because if you don't have the same variables, it's not possible that they're like terms. And now we want to check the exponents. So the x is squared in this first one, but it's raised to the 4th in the second one, which means that these are unlike terms. So the exponents have to match on the variables. So even though they both have a 2 and a 4 exponent on their variables here, they're on different variables, which means that they can't be like terms. Number 4, 7x squared y to the 4th and negative 7x squared y to the 4th. So this one, really similar. The only difference here is the negatives, but our variables are the same. We have an x squared, y to the fourth, y to the fourth. So these are like terms. Oh, jumped all the way to number 8. Number 5. Number 5 here, we're given 13kt and 4tk. So with this one, a lot of the time people see this and think that these are unlike because they're in a different order. But remember, multiplication is commutative, which means we can just switch these around and it's the exact same thing. So they have a t and a t raised to the first power, a k and a k, which means these are like terms. The ordering for the variables does not matter because we're multiplying. All right, now let's get into some examples where we start combining like terms. This is what we're going to be doing when we're simplifying expressions. And so number 1 here, we're given 4k plus 7k. And so now, first checking that we have like terms, we have a k and a k. All we're going to do is add our coefficients. So 4 plus 7 is 11, and we still have k's. One way of thinking about this, and it sounds really silly at first, but it kind of breaks it down into what we're actually doing here. Think of these k's as objects. So if we had 4 cars plus 7 cars, we still have 11 cars. That doesn't change. And so this is something you'll see or probably start to do when we get to multiplying and the exponents start to change. When we're adding, we're keeping the same object. We're keeping the same k. That's never going to change. Number 2, 4r minus r. This is another one where I tend to see mistakes because people see r's and they're like, oh, well, we're subtracting it. We just want to get rid of it. But we have 4 r's and we're subtracting 1 r. So we're left with 3 r's. Number 3, this one's a little bit longer, 5z, and I cross my z's just so they don't look like 2's, plus 9z minus 4z. We can do this all in one simplification, or we can break it down. I'll break it down first, and you can always just do it in one step if you want. Let's go from left to right. So 5z plus 9z gives us 14z. And then we want to subtract that 4z. So 14z minus 4z leaves us with 10z. And now the final one here, number 4, we're given 8p plus 8p squared. Now, if you notice with this one, our 8's match, but we have a p and a p squared. So I'm doing different underlines here because they're not the same. They're not like terms, which means that we can't combine these terms. So I'm just going to say cannot combine or cannot simplify, something to indicate that we can't actually simplify this down anymore. All right, so now let's go ahead and just write down the steps that we've gone through so far for simplifying. And this first one is one we saw last section. First thing you always want to do is get rid of parentheses, and we get rid of parentheses by distributing. So we want to distribute first. And then secondly, we want to combine like terms. So these expressions aren't considered completely simplified until you've gotten rid of all parentheses and all of the terms that can possibly be combined are combined. So always double check your final answer to see if there's anything else you can do. So now all we're going to do for the last part of this section is go through two different sections of examples. First one is just going to be simplifying a bunch of expressions. And then the last part is going to be a couple of word problems. So we're told to simplify. And so at this point, we're not told to distribute or combine like terms. They're just saying simplify, and they're assuming that we know what we have to do. And so for this first one, we're given 9k plus 12 minus 5. So first thing I'm doing here is checking for parentheses to see if we need to distribute. No parentheses. So now what we want to do is combine our like terms. There's no other term with a k, so I can't combine this, but I can take positive 12 and subtract 5. And I'm going to leave this 9k in the front. And then 12 minus 5 is positive 7, so plus 7. And now there's no incorrect order. If you would have put 7 plus 9k, that is technically correct because addition is commutative. However, this first one here is the better answer. We like to put our variables first and all of the higher exponent terms first, because when we start getting into factoring in the last chapter here, we're going to need stuff in a specific order. So try to get in the habit of putting all of your variable terms before the constants at the end. All right, number 2, 7 parentheses, 3p plus 2q. And now this one is just like what we saw in 1.7. So this one, if you notice, we have parentheses, so that's what we want to do first to simplify. We'll check for like terms afterwards. 7 times 3p and 7 times 2q. 7 times 3p, 7 times 3 is 21p, plus 7 times 2 is 14q. And now one of these has a p, one of them has a q. They're not like terms, so we're going to leave it just like this. Number 3, 10p plus 3 parentheses 5 plus 2p. And now this is one where order is really important. So this one, it's not as easy to mess up on because we can't combine the 10p and the 3 either way. But remember that multiplication, which is what we're doing with this 3 here, comes before addition. So before we can add any of these terms in the front, we need to multiply this 3 in. So I'm going to leave this 10p plus in the front, so we haven't used it yet. Think of this just like order of operations. And now 3 times 5 is 15, and 3 times 2p is 6p, so positive 6p. And now if we check for like terms, we have a 10p and a 6p, nothing to combine with this 15 because it doesn't have a p. So 10p plus 6p gives us 16p, and then I'll put this plus 15 at the end because it's still part of our answer. Number 4, we're given 7z minus 2 minus parentheses 1 plus c. So again, we want to clear parentheses first before we start doing any addition. This is one where it looks kind of weird, but remember this minus in front of these parentheses just represents a -1. So let's go ahead and distribute that -1 in, and we're going to leave this 7z minus 2 in the front. And I'm not going to put a plus or a minus here yet because we don't know what the sign is going to be for the first term. So -1 times 1 is -1. negative 1 times z is negative 1z, or negative z. We're going to just drop those ones off of the variables. Or you can keep it if you want, if you prefer seeing it there. And now we can go ahead and combine. So let's check for like terms. We have a 7z and a negative z. Remember, that's a negative 1z. So 7 minus 1 is 6z. And negative 2 minus 1 is going to give us negative 3. So remember from 1.4, 1.5, they're both negative numbers. You add them and keep the negative. And this is one thing that's really helpful here, using different underlines, because we will get to some cases where we're going to have 4 or 5 different like terms, and you're going to have to try to figure out which one goes with which. And so having underlines there just to kind of organize your work is always helpful for these. I still like to do it when I'm simplifying these. Number 5, negative parentheses 3k squared plus 5k end parentheses plus 7 parentheses k squared minus 4k. All right, so again, first thing we want to do is distribute. So if you want to go ahead and pause right now and see if you can get the distributing done, I definitely recommend that. Let's go ahead and distribute this negative 1 into these first 2 terms. And notice they only go into the parentheses that are directly next to them. I'm not distributing over here to the second set. That's where this 7 is going to go. So negative 1 times 3 is negative 3k squared. Negative 1 times 5 is negative 5, has a k with it. And now again, this plus sign just tells us that we're just going to be adding on these terms, but it still depends on the sign. So if we look at 7, so 7's a positive. 7 times k squared, or 7 times 1k squared, is positive, so plus 7k squared. You should always be adding and subtracting all of these. And then 7 times negative 4 is negative 28k. So again, positive 7, negative 4 gives us a negative 28k. So just be careful on those signs. And now finally, we can combine like terms. So again, see if you can pause and combine these like terms here. We go ahead and combine our k squareds first. Negative 3 plus 7, opposite signs, so we subtract, and it's a positive 4k squared. And then we have a negative 5k and a negative 28k. They're both negative, so negative 5 and negative 28 give us negative 33k. All right, let's go ahead and do just 2 more examples. Number 6, negative 3/4, parentheses, x minus 8, and parentheses minus 1/3 x. All right, so first things first, we want to go ahead and distribute. So negative 3/4 times x, because it's just an x, we don't actually have to do this multiplication off to the side. We just get negative 3/4 x. But negative 3/4 times negative 8, I'm going to do that down here. And I'll write it as negative 8 over 1. And I'm going to go ahead and reduce first. So 4 and 8 are divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. And now we have a negative times a negative, which is a positive. Along the top, 3 times 2 is 6. 1 times 1 is just 1. 6 over 1 is just 6. So we have a positive, so plus 6, adding that back up in on top. Don't forget to bring over this minus 1/3 x at the end. All right, so now that we have our distributing done, we can go ahead and combine our x's. And these ones have fractions, so we do want to go ahead and add those fractions together or subtract depending on what we need to do with the signs here. But I'll do it right down below. So we have negative 3/4 minus 1/3. And because we're subtracting, I'm going to go ahead and add the opposite. So they're both negative, so we know we're just adding our two numbers together. And now let's go ahead and get a common denominator, which is 12. So we have, for our first fraction, multiply it by 3. 3 times 3 is 9, so negative 9/12. To get from 3 to 12, we multiply by 4. 1 times 4 is 4. Don't forget to bring over these negative signs. And so now, let me go ahead and bring this negative up to the top to make it look a little bit nicer. Negative 9 plus negative 4 gives us negative 13/12. And remember, this was a coefficient in front of the x. So we have negative 13/12 x. And that negative, I put it out in front, could have stayed on top or gone to the bottom. And then plus 6. All right, that's the only tough thing with these when you start bringing in fractions is that you might have to do some kind of calculations off to the side. Can make it a little bit more confusing, but once you have those done, it's not too bad. Same kind of process as before. All right, let's try one more. 2 parentheses 5r plus 3 minus 3 parentheses 2r minus 3. So now this last one's really important as far as signs is concerned. This first one's not too bad. We just need to distribute this 2 into 5r and 3. So 2 times 5r is 10r. 2 times 3 is 6, positive, so plus 6. And now be really careful when you distribute into the second group. We're distributing a negative 3. So negative 3 times 2r is negative 6r. And negative 3 times negative 3 is positive 9, so plus 9. And now combining like terms, we have the r terms, so 10r minus 6r is 4r, and 6 plus 9 gives us a plus or positive 15 at the end. All right, so hopefully those aren't too bad. Again, just kind of ugly when you bring in the fractions, but otherwise it's just a matter of being careful with what you're distributing, what you're combining, and the signs on all of the terms. So now our last two examples here are going to be word problems. And so for these, we're told to write as a numerical expression. And then simplify. Always simplifying answers, just like working with fractions. You always want to reduce them down. We want everything to look the least amount of complicated as possible. All right, so number 1, we're given 3 times a number subtracted from the sum of the number and 8. All right, so it's an expression, so there's not going to be an equal sign to look for. So let's go ahead and break this down. 3 times a number. 3 times a number, you can pick any variable you want for the number. I'll usually just pick x. 3 times it means we're multiplying it by 3, so this is 3x. We're subtracting this from, so remember if you're subtracting something from something else, this 3x is going to go at the end. We're subtracting it from the sum of the number and 8. So remember the sum of groups these terms. And so we know we're going to be adding, because it's a sum, the number and 8. It says the number, not another number, so we're still going to use x. So the sum of a number and 8 in parentheses is going to be x plus 8, or 8 plus x because these are commutative. And now we want to take 3x and subtract it from this. So we're going to put minus 3x. So this here is our expression. We just want to go ahead and simplify. Looks a little weird to simplify this one because these parentheses in front, there's technically a 1 here, but multiplying by 1 isn't going to change this. So these parentheses aren't actually needed. So first thing I'm going to do is just get rid of them. X plus 8 minus 3x. And now I'll go ahead and combine like terms. So we have 1x minus 3x gives us negative 2x. And then we have plus 8. So normally with these, writing the expressions usually the hardest part, and once you have that, simplifying isn't too bad once you get a little bit of practice in. Our final example here, we're given twice a number added to the sum of 6 and the number. So again, key things I'm looking for here, twice a number is pretty easy to write down. Twice means we're doubling something, so we're multiplying it by 2. I'll use x again, so 2x. We're adding that to the sum of 6 and the number, group those. And so we're adding is commutative. Doesn't matter which order you put this in. So I'm going to go ahead and do the 2x first, adding that to parentheses, the sum, that's addition, of 6 and the number, so the same number x, so 6 plus x. And now again for this one, if we think of this as a 1 in the front, we want to distribute that in first, leave the 2x, 2x in the front. But multiplying by 1 doesn't change a number. So, and remember that's one of our identity properties. So 1 times 6 is still positive 6, so plus 6. And 1 times x is still x, so plus x. Or if you want to put 1x, you can. And now combining, 2x plus 1x gives us 3x plus 6. All right, so that was our first introduction to algebra here. So that's the end of chapter 8. Next time we'll take a look at solving some equations and start up chapter 2.